what is the physical quantity which has unit kilogram second minus 2? Okay, all you know that kilogram meter second minus 2 is the unit of force, but here is no meter. How is possible? It is only possible by dividing kilogram meter second minus 2 by meter, which means I am telling you kilogram meter second minus 2 is the unit of force, which is force. How can you make this equation to kilogram second minus 2? By dividing meter, no? So by dividing meter means is force over length. Okay, the force over length is what? This is what we call surface tension. So what do you mean by surface tension? The surface tension is the force which acting on the surface of liquid. And we have two definitions for the surface tension. The one is according to the force, and another one is according to the energy. Okay, the unit amount of energy of the unit area of the surface of liquid. Okay. Okay, all you know that I don't have to talk more. Uh, Surface tension is the answer one. So even I'm just trying to remember another quantities. Okay, the tension. What is tension? Tension is nothing. Tension is just a force. Energy. Okay, energy is force in energy is means work. You can take it both are similar. So energy is force. Force into the distance which moved in the direction of force. Okay, the energy is F into S. So F means kilogram meter second minus 2 into meter. So the unit of energy will become like this, kilogram meter squared minus 2. So this is not the correct answer, I'm just remembering. The answer is third. The power is energy over time, so you have to divide over second. So the answer would be kilogram meter squared second minus 3. And all you know, the heat conductivity, the unit of heat conductivity is watt meter minus 1 Kelvin minus 1. You can substitute, you can use the for watt. That is that. What is the watt? Watt is just power, so you have to put here for watt. Power means here, this is the power. Okay, sorry, this is the power. So kilogram meter squared second minus 3 into meter minus 1 into Kelvin minus 1. So therefore the meter minus 1 in the meter squared will be cancelled, and the answers would be kilogram meter minus 1 second minus 3 Kelvin minus 1. This is the unit of heat conductivity with representation of kilogram meter second. Okay, so for this question the answer is 3. I am just remembering all other units, that's it. Okay, the second question is the circular scale of spirometer with 1 millimeter pitch is divided into 100 parts. The magnitude of the measurement shown in the figure is. So whenever if you want to take measurement using the spirometer, you have to get to know about the least count. How do you calculate the least count in spirometer? The least count has been calculated by the pitch length over the divisions. Okay, according to their data, the least count is equal to 1 millimeter over 100. If you want to get to know about well about the spirometer, you can check out through this channel. I have uploaded a video about the spirometer, and if you watch it 100%, you will get a 100% clear cut idea about the spirometer, and then you can come to this after you come to this. Okay, the least count would be 1 millimeter over 100, which is equal to 0.01 millimeter. Okay, I have concluded the least count. Okay, now we have to see this figure. Okay, this figure shows me that the circular scale is moved downwards. Okay, 0 should be here. This is only possible. 0 should be here. So the all you know that the measurement is you have to take the main scale reading, which is 0, 1, 2, 2 plus something. The something is measured by the circular scale. So what is that something? Okay, I'm just remembering that if you go downwards, you have to substitute this reading from 100. So the real reading would be, because of you are moving downwards. Why we have to substitute from 100? Okay, the point I have discussed in that video. So if you're not clear about it, you go and check out this channel and see that video, and you will get a clear idea. Now just move this. Okay. Okay, now the answer is 0 1, so 2. 2 plus 100 minus 35, 100 minus 35 into least count, which is 65 into 0.01. The answer would be 2.65 millimeter. Okay, the second answer is right one. Okay, the third one, the question number 3. Radio waves, microwaves, gamma waves, X-rays. According to the above types of waves, which has the maximum and minimum wavelengths respectively? Okay, for answering this question, you have to get to know about electromagnetic spectrum. What is electromagnetic spectrum? Okay, the electromagnetic spectrum is created or designed by human. For example, according to UN statement, we have 193 countries in this world. How we classified? We have created a map. We have created a map, and we have put all the countries together in this map, and we just addressing them. Similar to this, there is 8 types of electromagnetic waves, and we have created list, and we have created chart. This chart is called electromagnetic spectrum. The way we created this spectrum is increasing frequency downwards. So I'm just remembering all the electromagnetic spectrum waves. The first one is radio, TV wave, microwave, IR infrared, visible light, UV, X-ray, gamma. Here you can see 1, 2, 3, 4, 5, 6, 7, 8. How we created this spectrum? This spectrum we have created is increasing frequency downwards. So all you know that in vacuum, in vacuum, in air, the speed of electromagnetic waves is never going to be changed. So C is equal to F lambda. According to this equation, the C is never going to change. So if we go downwards, the frequency is increasing. Similarly, the lambda, the wavelength should be decreased. So according to this, if we go downwards, the frequency is increasing, so the wavelength should be decreased. So the higher the wavelength is upper top position, top of this chart. So when you go upwards, the lambda is going to be increased. So according to this, their question is which has the maximum and minimum wavelengths. Okay, the maximum wavelength is radio wave. The radio waves has the maximum wavelength, so the radio is A, and the minimum wavelength is gamma rays. Okay, so radio and gamma, AC the first answer. Okay, first answer. I'm just remembering something new. The wave which has higher wavelength will diffract higher. So that is why we have a few little amount of radio station in this our country, because the higher the wavelength of radio waves, because of the okay the radio waves the radio wave has higher wavelength, which is create a good idea about the diffraction. The diffraction will be increased with wavelength. This is just point. This is a point I just want to remember you. Okay, the question answer is first one. Okay, the fourth question. When a ball is projected downwards, it will collide against the ground at 20 meters below and rebound to the same height. If the 50% of the energy is lost in the collision, the projecting velocity will be. Okay, the incident which they are telling is, you have a ball above the surface of 20 meter, and you are project this ball downwards, and this ball coming down and collide with the surface and bounce back and what is it? Okay, and bounce back, and it is go to its initial point, so the initial point is above the surface 20 meter. So okay, and they are mentioning that the 50% of energy is lost in this collision. Okay, according to this data, it is not possible. It has an initial velocity downwards. It is not possible. It has a zero initial velocity downwards. it has to be some initial velocity downwards. That is why it has a higher initial velocity, and so the higher initial velocity create the higher kinetic energy. This higher kinetic energy and the higher potential energy is the total make this ball has a higher total energy. So that is why when this ball is come downwards, it lost this only kinetic energy, sorry, only the potential energy, but even it has this kinetic energy. So total energy is here is equal to the initial kinetic energy, ek plus e potential energy. Okay, this is complicated, I'm just telling you the simple way. Okay, after the collision, I'm just considering after the collision it has energy which we call is E. So according to their data, it lost 50% of energy by collision. So the before the collision, after losing 50%, it has energy E. So the before the collision, it has total energy is 2E, 2E. And here you can see by having this energy E, which is enough to go upwards 20 meter of potential energy. So what do you mean by this thing? Which is represent you that this 1E is enough to go 20 meter above the surface, which means 20 meter potential energy. So this E is enough to 20, okay, E is enough to 20 GH. Okay. So before the collision it has to be 2E. How is 2E? How this ball get this 2E before the collision? It is only possible that it has to be totally before the initially this ball consists totally 2E. The one E is by the potential energy, the another E is its initial kinetic energy. So finally I can conclude that the ball initially has 2E, 2E total energy. The one E is its kinetic energy, and another E is its potential energy. So by coming down, the potential energy will be decreased and the kinetic energy will increase. However, the total energy is conserved before the collision. So I can create an idea about there are 50% energy loss. So the E is equal to the one E is equal to 20 mgh. So this E is the initial kinetic energy, half mv squared is equal to mgh. So the mm will cancel. So v squared is square root 2gh. Why I am writing this? Because of E is equal to mgh. Why I am telling this? Again I am remembering you, after losing 50% it has E. This E is enough to go upwards 20 meters. So this E is enough 20 mgh. Sorry, 20 gh. So this amount of energy E is the initial kinetic energy. The initial kinetic energy is only responsible for the initial velocity downwards. So the V is 2 into 10 to H is 20. So there is a square root, so 400 square root of 400 is 20 meters second minus 1 is the initial velocity downwards. So the answer was second one. Okay, the question number 5. Okay, a piece of ice was immersed in a coil which float on water as shown in the figure. By connecting a metal spare to the other end of the string which connected to the piece of ice, after the piece of ice was completely melted, what can happen from the following? Okay, the question is, here is an ice cube and this is a metal sphere, and this is string. Okay, according to this figure I can conclude that the metal sphere has higher density than water and the oil has lesser density than water. That is why the oil is floating over the water. If not, the oil should come down. Okay, and the ice cube, this is ice cube. Okay, for answering this question, you have to have a clear cut idea about the idea is density. You have to well known about density. What do you mean by density? Density is nothing. Density is the amount of mass in unit volume. The amount of mass in unit volume. For example, this amount of volume, I am saying that this amount of volume, you have a stone and you measure this mass, it's almost 2 kg. This amount of volume, you have a sponge and measure this mass, it will be like 100 grams. So the volume is both are same, both are have the same volume but not equal masses. So this is what the God has created. Every object has different densities. So the density means the unit mass, sorry, the unit, okay, the mass in a unit volume. So that is what we call is density. So according to this, I'm going to draw this image on my paper. So okay, so initially the ice cube, and also you have to just remember, that ice cube, the solid ice, I mean ice cube has lesser density than water. The water has higher density than ice cube. That is why if you are going to drink any cool drinks, when you put the ice cube on the water, the ice cube should float on the water, it's never sink. So the reason is the reason is the ice cube has low density than water. Okay, so what do you mean by the low density? In a unit volume, the mass is in ice cube is lesser than water. So in a unit volume, if you take 1 liter of ice cube in 1 liter of water, the weight, the mass, I mean the weight is higher in water. Okay, right. So in this paper, okay, so you have to be clear about density. Okay, now I'm going to draw this image. Okay, so this is the ice cube and this is sphere. So okay, now let me tell you that initially it is ice cube. So you know that the initial amount of mass in this ice cube has to be equal after the melting, and it has to be converted into water. Whatever the mass will be conserved, the mass is never going to be changed. So initially it has higher volume with same mass. So after after it transform into water, the volume has to be decreased. The volume will become like this. Why it's shrink in volume? The reason is the density difference. So initially it is ice cube, so after melting it will transform into water, so therefore the volume should be decreased. So by decreasing this volume will create a force downwards, I mean the oil will be fill up this space. And also meanwhile, now it's transformed into water, the water can't stay here. The water has higher density than oil, so the water should come down. So this is the answer. The water when its the ice cube is melt, the water should come down and it's create an increase in the height. So the water level should increase. The water level should increase. Meanwhile, when the water level should increasing, so the level of oil has to fill up the space. The level of oil has to fill up the space. So to fill up this space, it has to be decreased in the length. So the final answer is the water level is increased upwards, and the oil level should decrease. So the water level and oil level both are rise up. No, only water levels rise up. Water level is rise up and oil level is rise down. Okay, that is right. Water level is rise up and oil level is rise down. The oil level is rise down. Okay, that's good. Oil level is not changed. No, it has to change. How is possible? Even you can think simply. If this volume of ice is melted and it is converted into water, then it should come down. How is possible to fill up this space? Who is responsible for fill up this space? It's only responsible for this oil. This oil has to come down. Okay. Okay, this is not clear, so otherwise the second one is correct one. Okay. Okay, what is the acceleration of m2 in the given figure? The plane and the pulley are smooth and the string pulleys are light. Okay, according to their data, there is no frictional forces and all other smooth, so we can conclude that there is no frictional forces. Okay, according to this image, first of all we have to conclude how the motion will be, and then only you can apply the Newton's laws. So now we are going to conclude how the motion will be. So I'm going to write it. Okay, this is the image. This is M2, this is M2, this is M1. Okay, okay, how will be the motion? I'm just asking you, if this mass just displaced x in downward direction, what is the displacement of this mass? Okay, if this mass is displaced from distance is just x, therefore this string has to be, this length of string has to become x downwards, the length x downwards. Same time this length should go x direction upwards, then only it's possible to, this pulley and this mass can move downwards with the distance x. If this move x direction and this pulley, if the string also moves just x direction, so it is not come x length, it has to be x by 2. So therefore it has to be move x distance, then only the string also has to move 2x. The x is come here, another x has to go upwards. So if the string has to move with 2x direction in the same time, therefore it has acceleration a, this mass has 2a acceleration in this direction. This is the only possible way of accelerating. So therefore, okay, this is the way of I analyzed. So now they are going to use Newton's law. So when the mass m2 is acceleration is, I am considering it's a, so according to the Newton's law, for this mass acceleration a is resultant force on acting on this force. So I am telling that for this m2 mass, the, okay, here I'm considering tension t, so this has no mass, therefore it has to be 2t. So for this m2 mass in downward direction, m2g minus 2t. Okay, now I'm going to put 2t. What is t? T is equal to m1 into 2a. Because of this tension is the reason, this tension force is the reason for the m1 mass acceleration. So the t is equal to 2m1a. So therefore 2t means 4 m2 my m2g minus 4m1a over the net force. This is the net force acting on this m2 mass over m2 is equal to a. So I have to get the answer for the a. So I am multiplying this m to this direction. So m2 into a is equal to m2g minus 4m1a. I'm going to add this 4m1 in this direction, so you can take a outside. So a is equal to m2g over 4m1 plus m2. So what is the answer? So the answer is okay, the first one is right answer. Okay, the seventh question. This question is not clear, but I can just draw it for your understanding purpose. Okay, as shown in the figure, a chain of length is greater than, sorry, is smaller than h, is kept on the smooth horizontal table and released if the motion is started at time t naught. The graph which shows the variation between the velocity and time until the chain touch the ground. Okay, the question is just like this. It is not clear, so the question has to be, I am not confirmed, but according to this question and their data, the question has to be like this. Okay, this is a stand and this is a mass. Okay, here is a chain. All you know, the chain has rings. Okay, okay, and this is h, and they are mentioning that this length of this total length of this chain is lesser than the h, this height. So what is they mentioning? They're mentioning that it's never going to touch until this end is passing through this edge. Okay. This is simple question. You can see that initially they're telling that if the motion is started at t naught, if the motion is started at t naught, okay, okay, for this total unit, the net force is the mg. The net force is mg. So all you can feel that when this rings is cross this edge, every time this mass acting downward, this mass is crossing this edge, which create higher mg forces, higher gravitational forces. With time, the total mass of this object is conserved. It's not going to be changed. So therefore, increasing downward forces for this total unit is increase the acceleration. I mean, F is equal to ma. Initially you can ask, initially it is mg, okay, it's mc. This mg is equalized by the normal force, but here after crossing this edge there is no normal force, so therefore the mg is net force acting downwards, which creates the acceleration. So therefore the F, so increasing force downwards, the total mass of the chain is never going to be changed. The force increasing means the acceleration increasing. The only graph which represents the time, with time the acceleration increasing, so this vd graph, uh, this first one is right one. You can feel it, initially it only 1 mg will act downwards, so no, low force. After it starts to move with time, so much of mass have to cross this edge, which create many downward forces by gravitational force, but however the total mass of this chain is be same. Therefore the m is same. By crossing this edge, the force will be increased. Increase in force creates increase in acceleration. Only the graph which represent increasing acceleration is first one, so the answer should be first one. Okay.